In this video, we're going to examine the following problem. We want to know, does f of x equals 2x squared minus 12x plus 14 have a maximum or minimum value? And then we want to know, where does this max or min occur? And so really, this problem is a test over, honestly, some vocabulary, kind of understanding the concepts, connecting the ideas of maximum and minimum to a vertex. It's also going to be a problem that's going to involve some logic, some figuring out from the problem whether we're going to have a max or min, and then ultimately figuring out where the max or min occurs is just going to test our ability to say, hey, that's the same thing as the vertex, and our ability to use the vertex formula, given the quadratic in this particular form. So let's go ahead and talk about the relationship between a vertex and a maximum and a minimum value. So we have a quadratic, we have 2x squared, so to the second power, and we have no other powers higher than that. And we have a linear term and a constant term. So we know this is a quadratic, and we know the graph of this is going to be a parabola. And so what this is going to be like is it's going to be a U shape, and it's going to be a U either opening up or it's going to be a U opening downward. So depending on which case we have here, if the U is opening upward, our vertex is this point that I'm kind of coloring in green right there. That would be the vertex. But also notice, since the parabola goes up to the right and up to the left forever and it's never going to turn back around, that's also going to be the minimum value, or the lowest y value that's ever going to be represented by this graph. So now looking at the second potential case where we have the parabola opening downward, again, the vertex, I just colored it in green, in this case is going to be the maximum value, or the highest value that you ever attain, the highest y value. And the reason being because this is a U that opens downward forever, so it keeps going down. It never curves back and attains a higher value than the vertex. And so the vertex is what you want to look at when you're figuring out whether it's going to be a max or a min. This is really the same thing. The vertex is either going to be a maximum or the vertex is going to be a minimum. Now, as far as figuring out which one it is, we just need to know whether this parabola opens upward or downward. And to figure that out, we just need to look at the leading coefficient, or the a, if you think of the a, b, and the c, just like we would with the quadratic formula. So our leading coefficient, the coefficient or the number connected to the x squared term, is a positive number. And if it's a positive number, then it's going to be a parabola that opens upward. If our leading coefficient were a negative number, then it would be opening downward. So in this case, 2 is positive, so it's going to be the case that I boxed in green. We're going to be opening upward. Therefore, if we're opening upward, that vertex is going to be the lowest value, or a minimum value. So for 2x squared minus 12x plus 14, we definitely have a minimum, and that's going to be represented by the vertex. So minimum. Now we want to figure out where this min or max occurs. Well, we know, of course, it's a minimum. So we want to know where this minimum, or where the vertex for our quadratic, is going to occur. So to figure that out, we're going to use our vertex formula. And the vertex formula is x is equal to negative b over 2a. And so we just need to label our a, b, and our c. Well, our a is going to be 2. That's the coefficient of the x squared term. Our b is going to be negative 12. That's the coefficient of the linear term, or the term with just an x. And so plugging that into our vertex formula, the x value for the vertex is going to be negative b, so negative 12, all divided by 2 times a, so 2 multiplied by 2. Now we simplify this as much as we can. Negative times a negative is going to give us a positive 12 on top. 2 times 2 is going to give us a 4. 12 divided by 4 gives us 3. So our x value for the vertex, or for the minimum, whichever way you want to refer to it for this particular problem, is going to be 3. But we want to know what the vertex is. Now, technically, we've already answered the problem because the problem says where does the max or min occur. And so anytime you want to know where, that's the same thing as wanting to know the x value. But just for the purpose of, so you know how to find the corresponding y value, I'm going to go back and figure out what the y value is for our vertex also. So again, you don't have to do this if you just want to know where the max or min occurs, because typically if you're asked where, that's just saying where is it on the x-axis. That's kind of like your way of orienting yourself. But let's go ahead, like I said, do a little bit of extra work. So if we want to find the y value for this 3, the corresponding y value, we're just going to put 3 into the place of x. So really we're going to be evaluating the f of 3. And so everywhere we have an x, we're going to put a 3. So 2 multiplied instead of by x squared, it's going to be multiplied by 3 squared. Minus 12 times instead of x, it's going to be 3. And then we're going to have plus 14. And now we can simplify this. So do the x first. So 2 is going to be multiplied by 9 because 3 squared is going to give us 9. Negative 12 times 3 is going to give us negative 36 plus 14. And of course 2 times 9 is going to give us 18 minus 36 plus 14. And 18 minus 36 is going to give us negative 18 plus 14 is going to give us negative 4. And so negative 4 is going to be the y value for this corresponding x value of 3. And so the overall location, the actual ordered pair that represents this minimum value or our vertex, is going to be 3, negative 4.